Hello dear students, welcome to the last lesson of module 6 that is the logarithmic functions. But in this lesson we will deal with exponential and logarithmic functions. Exponential functions is what we studied in module 3. Let's get into the learning objectives, that is to write and solve exponential growth equations and inequalities, and to write and solve exponential decay equations. So it is growth and decay. Growth is always growing, it will be plus, decay is decreasing, minus. We will look into both these objectives in this video. And now we will see how to solve these problems. So now you already know continuous growth function. This formula was something we have used earlier. So this is it. We will be using the same formula. Here E means something that grows continuously. Remember in the previous lessons we had this E Euler's number where it is always continuous, compounding or continuous growth, you can say in this case. So whenever something is happening continuously, you use this E function. If you have forgotten, please go to the previous videos where this was already explained about the compounding and everything. So that this E will usually come when it's continuous, and now we are dealing with continuous exponential growths. Now this is the thing, we had dealt with this formula, sorry, not this one, this formula we had dealt with, that was continuously compounding interest, where A was the amount after certain time and P was the initial amount, what was invested, or that initial amount that was given. E is Euler's number, R is the rate of interest, and T is time. Now similarly here, Y, if you're dealing with population growth, it would be population after certain time. It can be after 10 years, 20 years, whatever they are asked you to solve. A is the initial population, K is the rate of continuous growth, that is the rate, similar to rate of interest, there will be a K value, rate of continuous growth, which will be a constant, and T is time. So we will see a problem you'll understand much better. Now we have this population problem. In 2016, the population of Florida was 20.61 million people. In 2000, it was 15.98 million. Write an exponential growth equation. Now, here, first of all, we know the formula. This is the second form. It's the same, but we usually use the second one. Let me just write it. Y equals A, E, K, T. Now, one thing, this is growth. Okay, so this K is always positive. If it was decay, it would be minus. That's the only difference. We'll see it in a while. Now here, Y is after certain time. Now, what is initial? Initial is before certain time. Now, if I have two values, say something has happened at time, you can take it as day 25. And then I tell you before in day 15 it was so and so, which is the initial value here. Though if I mention 25 first, that doesn't mean that this is the initial value. Always the ascending order is important. So day 25, even if I mention first, and I should write it like this, day 15 is mentioned later, the first initial point which we know is day 15. It's always ascending order. Why I told this is just over here, you can see 2016 is mentioned and then 2020 is mentioned, but it doesn't change the fact that 2000, whatever population is there, is the initial population. So now what you need to do is, over here A value is always initial, what is at the beginning. Now we know only two values, 2000 and 2016. So the initial population will be A, that is 15.98. This is A value, that is the initial population. Then E is as it is. What is K value? K is not given. That's why we need to find that to write the exponential growth equation. Exponential growth equation is this, but we need to know the K value. K is unknown. What is the time? From 2000 to 2016, time is 16. What is this final? After 16 years, what happened? The population was 20.61. See, now this is all the knowns. We know A, we know Y, we know T. T is the time from these two. So if we put this in the equation, we will find the K value. So this is what we are going to do now, because we need all the variables, right? This constant is very important. T will be given, A will be given, Y will be given, E is constant. K now can be found out. You can use logarithm on both the sides and solve, but now I will just solve it directly. 20.61 equals 15.98 multiplied with exponential shift E. This K means its unknown value, x into 16. Now you can press shift and solve, you'll get the answer. K is 0.0159 or 0.016. Now here, okay, anyways, we will just see the answer directly, and I'll tell you how to do it. So now we got the same answer, 0.0159. Now this is the relative growth. We don't write in percentage, we can write it as 0.0159 itself. This is very important. This is how we found the K value. And once you found the K value, what is known? The initial population is known. Write that. E is constant, 0.0159 T. So at any given time you can find the current population. So now if you want to find, say for example, at the year 2020, you should just put year T as 20 years and then you will get Y of 2020. So over here 2016 and 2000 was given, and from these two dates we know the population, initial and the final for 2016. From the time of this and from this final population, we can easily find the K value. Now if you're thinking how the steps are done, it's very simple. Now whenever you have problems like this, what do you have to do? You need to simplify as much as possible and then take ln, the natural logarithm. Don't take ln now on both the sides. It'll just be more complicated. You will get the answer, but it'll be more complicated. So what do you need to do? Take this 15.98 to the other side, because it's multiplied to the other side, it becomes division, or divide both the sides by 15.98, and then you will get okay, everything is done at once, that's fine. Now take ln on both the sides, that's natural logarithm. Here you will get ln 20.61 divided by 15.98. What happens to the right side? You have E, so ln E 16k, k is unknown. Now here this cancels off because they are inverse, and whatever is there comes down, the power comes down, right? So whenever you have natural logarithm base and a power, that power comes down. So write 16k only, and ln E, see this is the rule. Whenever you have any log function, even you can have any log base function, and say you have a base of 2 and then the power of 3. This is equal to 3 log 2. Okay, so now the same thing we had over here, the power, right? We had ln E 16k. We can write it as 16k ln E. But now log E is natural logarithm, so log E and E over here will cancel out, it's equal to 1. So that's why this is not written over here. Natural logarithm E is equal to 1, so we just write this 16k. Next, here you just need to put this in calculator and solve. Okay, now before that, I forgot about the 16. Take 16 to the other side. Now put entirely everything in the calculator. Natural logarithm, you have to use calculator. There is there is no other way to solve. Divided by 15.98, sorry, 0.98, close the brackets, and then we get 16 divided by 16. The answer is whatever we got directly as well, and that is the growth constant. And for the equation, see, this is the formula, right? Only thing is over here, y must be kept as a variable and t must be kept as variable, and everything else we just fill it in. This is the first part A. Now what about part B? Predict when the population will reach 25 million people. See, this formula is there, right? Now we should see what time t will it reach 25 million. Now this is the given equation, right? We had just now over here, just instead of y, put 25. Okay, instead of y, put 25. Why? Because they have asked for 25 million. Now, initial population was 15.98. E, the constant we found out just a while ago, 0.0159, and time t is unknown. That is what we are solving for. You can put it in directly in the calculator, or we will do the method, take this 15 to the other side. It is 25 divided by 15, that is written directly over there. Sorry, 15.98. which is equal to 1.564. And then now take natural logarithm on both the sides, the same thing. And now what happens? Here, whatever is in the power comes down and this cancels off. So you're just remaining with 0.159t, and take the 0.159 to the other side, divided. Natural logarithm 1.564 divided by 0.0159. This is the time, and the time is 28.129 years. We can do this directly in the calculator. Let's just double check. 25 equals 15.98 e to the power 0.0159 into alpha and x. You need to press shift and solve. This is the previous stored answer. You need to press equal to, you'll get the answer. Okay, here it is showing more accurate answer, but it's fine, it's almost the same. Okay, now the thing is, here we have taken some decimal points. We are not taking exact values. That might be the change. So whenever we do calculation, we may not take all the values. Here sometimes you might take the value. So here and there a little bit of difference, but it's almost the same thing. 28.1 years. So it'll be after 28.1 years. Now where is 28.1 years? Now how many years from 2000? It'll be 2028. So the population over here, the population, see, let's just go back to the question 1 second. The Florida's population in 2016 was growing to 20.61, right? But in 2028 it would reach 25 million if it was growing at a constant rate. So that is the thing. So that's what we found in the part B, 28.129. And now that'll be in the 28.129 means it'll be 2028. That is when it will reach 25 million. Now the part C over here, compare the populations of Florida and California. So they have given another extra thing. So California was never in the picture, but now they are telling California's population in 2000 was 33.9 million. And its population growth can be modeled by this particular equation given here. Determine when Florida's population will surpass California's population. You can see that the population growth constant here is bigger than this. So that means eventually Florida will catch up to California's population. Though it is more initially, Florida will surpass it eventually after a certain time. Now they are asking when. So what you need to do is, see, this equation is there, right? We need to just find the equation which is known for us, say Florida's equation, that is over here. Only this part, when will it be greater to 33.9 e 0. This equation. So this is what we will have to solve. See, 15.98 exponential e 0.0159 t greater than 33.9 e 0.0092 t. This is it. Now there is inequality. Don't directly solve in calculator, simplify how much you can. Now since there are exponent on both the sides, you can directly take natural logarithm on both the sides, or you can take 33 to the other side, simplify one side, but just take natural logarithm both the sides. Now here what happens? Here you will get okay, one important thing is I have to recall some properties of logarithms. What happens if you have log of a into b? It is log a plus log b. I hope you remember we had done this in properties of log. Same way over here, if you have natural logarithm, now we are dealing with ln. If you have ab square, it's the same thing. What's going to happen? It will be ln a plus ln b square. Now same thing is what we will apply over here. Natural logarithm to the first part, 15.98, which is multiplied to e, right? So that plus natural logarithm second part e and then the power. Same thing over here, natural logarithm 33.9 plus the second part. And now what you do is, these are numbers, constants, it's fine, you can get in calculator. What do you want? T and t. But here this cancels out and this comes down. So you're remaining with 0.0159 t down, and this also comes down here, 0.092 t. And now take all the numbers to the one side and take the t's to the one side. Since 0.0159 is bigger, leave it over here, take the smaller variable to the other side. So 1, okay, over here what happened? Okay, they have directly done it over here, but let me just show you. So what you do is 0.0159 t minus 0.0092 t is greater than natural logarithm 33.9, and this goes to the other side, will be minus ln 15.98. Now we here remove the t common. When you remove t common, what's remaining? You're remaining with these two constants, 0.0159 plus, sorry, it's minus 0.092. Okay, 0.0092. Remember, the t is taken as distributive property, so this is gone common. If you multiply this inside, you're getting the above equation, so it's balanced. So you're removing this outside, and whatever is there needs to be divided at the right side. This as it is. So I'll just put 2 lines. This is the 2 lines. And now what you do is, this 2 lines divided by this one. Okay. We will just do it in the calculator. What we have to do is the right side. The right side is ln, that's over here, 33.9 minus, no, please remember to close the bracket, minus natural logarithm 15.98, close the bracket, divided by 0.0159 minus 0.0092, and this is the answer. It'll be after 112 years, the final answer, 112.25. So this is how we can directly put it in the calculator and solve. Here what they did is 0.0159 t 159 minus 0.092 will give you this much. It'll be 0.067. So this is how you can solve it up. It's very straightforward. Directly you can solve it. Since inequality don't go to solve directly, solve it step by step, and then you will get the answer over here. So this is the answer. Now that would mean 112 plus 2000, it will be 2112 year it would surpass California's population. So this is the answer. So that's the first question, continuous exponential growth. Now what we can do is we can try this by ourselves. Please try pausing the video, solve the problem by yourselves, and then check the answers. I'll be explaining it in a while. Sorry. I hope you paused the video and tried it by yourself, at least few of you, or at least you paused the video and went through it, you know. So now let us solve this. So over here we are. Okay, I'll directly try to do it in calculator because it's just like the previous problem. First, we need to know the formula. Y equals A, E, K, and T. Now, what is given over here? An experiment starts with 20 bacteria A cells. After 45 minutes, there are 710 A cells. So initially, how many there were? A is 20. E to the power K is unknown. After how much time? 45 minutes. So multiplied by 45. How much was the final bacteria? So this is it. Initial value, time, final Y. Put this in calculator. 710 equals 20 e to the power, that is shift and natural logarithm. K is unknown, that is why let's put alpha x multiplied by 45. Now you need to press shift and solve. Let's see what's the answer. K is 0.079, 0.08. So that will be your first answer, 0.079. I hope this is clear. Now here you don't write Y because they will give us different values and we need to find. So we keep the final answer, final bacteria and the time variable, whereas the initial is 20, write it out. E is constant, 0.079. What next? Here there is 1000 bacteria, right? So sorry, after how many, part B, okay, this is the second part. After how many minutes will there be 1000 bacteria A cells? Round to the nearest tenth if necessary. Now here what you do is, Y is given as 1000, T is unknown. Everything in this equation remains as it is, just that the Y over here changes to 1000, and over here 0. Okay, sorry, this yeah, this is time, right? That is unknown, and the K value we just now found out was to be 0.079. Now you should just press shift and solve. You will get the answer 49.5 minutes. So 49.5 minutes the bacteria will grow to 1000. So this is the answer. Now what next? Now one more thing, exponential growth. Now you might be thinking, in 45 minutes it just grew to 710. What about this? See, it is an exponent. Okay, I just now realized in the last problem I told continuous growth. Sorry, I mean constant. Sorry, it's not constant. It's always exponential. Exponential means like this. Constant is a flat line. So what happens in exponential is, when you see, is initially it will take time, but once it increases, it will go up and up. So you can see as the bacteria are increasing, in 45 minutes there are 710 bacteria. So just within 4 minutes it will grow 300 more. But the first initial, it will take a lot of time to grow. Why? Because there are very less population growth. So it takes time, but once as population keeps on increasing, right, they keep on growing. So that is the thing. Now here we got 49.5 minutes. Now let's see, bacteria B grows exponentially according to this model. Okay, the same thing what we had done a while ago. How many minutes will be there? Sorry, let me read it properly. I am not able to focus well because I'm a little bit sick, but I had to do the videos because the lessons are going on, so that's why I tried my best. So sorry if I'm very clumsy in this video. Please do bear with me because I'm doing very silly mistakes, I just realized, and that's because I'm a little bit sick now. Anyways, back over here, part C, bacteria B grows exponentially according to the model Y equals 52E 0.064T. And after how many minutes will there be more bacteria A cells than B cells? See, now this is bacteria A cells, right? Now we can see the exponential growth over here is little more than this. The K factor constant. So that means eventually this will surpass, the A will surpass. So what you need to do is, whatever this equation is there, 20 e to the power 0.079, when will it be greater than this one? 52 e to the power 0.064t. We did the same thing in the last problem as well, but the values were different. So now we have to just solve this one. Okay, so I will directly use the calculator because we have done the same method. You have to just take natural logarithm on both the sides and solve. Okay, now there's a problem. Sometimes in calculator you won't be able to solve inequality problems, though you put equal to. Let's just try it out. Equal to 52 e. Okay, sorry. You need to press this. Now here equal to 52 e 0.064, and now t is unknown over here, and even over here t is unknown. Okay, now let's press shift and solve. Let's see whether we get the answer. Okay, we are not able to solve because there are two, because it will be a huge computation, right? So that's why we are not getting the correct answer. Anyways, we will solve it now manually. I'll try to do it in simple steps as possible. Take natural logarithm on both the sides. It'll be ln 20 e to the power 0.079t greater than natural logarithm 52 e to the power 0.064t. Now you need to use the the property of logarithm, where you need to plus this. Sorry, let me just write it over here. It'll be ln 20 plus. Now I will write it directly because natural logarithm and e cancels out, so you're remaining with 0.079t, which must be greater than ln 52 plus 0.064t. Okay, and now what you do is you take this ln to the other side, and sorry, this is bigger, so leave this over here, 0.079t. Take the other thing to the other side, minus 0.064t, and must be greater than ln 52 minus ln 20. Now what I'll do is I will just rearrange the step. The t is removed common out, so I'll just write t outside because both the terms are having t. And now this term must be divided by the right side. I'll directly do it. Natural logarithm 52, close the bracket, minus natural logarithm 20 divided by 0.079 minus 0.064 equals 63. So it will be 63.7 minutes. So this is the answer. Now let me just let me just tell why this didn't work in calculator. The reason is because there were two variables on both the sides and in the power. So it works if it's a simple problem, but when it's exponential with all this, the computation just becomes very high and it doesn't work. But if you try, say for example, this equation, now you would get an answer. So if I just want to show you, I'll do it over here. Now this one, natural logarithm 20 plus 0.079 alpha x must be equal to natural logarithm 52, close the bracket, plus 0.064 alpha x, shift and solve. Now you're getting the answer. The only thing is, whenever you remove this exponential, the computation becomes low and it can give you the answer. But here, since the power t, it'll be a huge computation and it won't be able to be solved by the calculator. It'll take a lot of time, but it'll not be able to solve it. So whenever there's inequalities, when both the sides you need to find a variable, try to solve it manually, or at least few steps, and then you can do it and you'll get the answer. So that's how you solve these problems. Now we will look into the decay problem. It is just like what we have done a while ago, but only difference is over here you will have minus. The minus indicates decay, that is reduction. Now we will see it's the same thing what was done at the beginning, you can see, but only the minus sign. We will see it now. Here, the half-life of a radioactive substance A is the time it takes for half of the atoms of the substance to disintegrate. The radioactive substance thorium-230 is used to determine the ages of cave formations and coral. The half-life of thorium-230 is 75,381. Now, see, various chemical substance, all of the chemical substances have something called half-life, but various different ones are used for different purposes. Say for example, dating of bones or certain things, fossils and all, we use carbon-14. Now coral, these can be many thousands of years old, right? Some of these. So that's why we use thorium-230. Why? Because the half-life is over 75,000 years. What is this half-life? You will learn more about it in chemistry, but in simple words, now imagine you have something. Yeah, say imagine you have a can of juice. Okay, so this is 100%, right? This is 100% now. So you're drinking it. How much time will you take to drink exactly half of it? That is 50%. So now imagine 50%, you reach the 50% mark in 2 minutes. That means it took 2 minutes to reduce to half of it. But now over here, similarly, in the chemical substance, what happens is the half-life means it'll take so many years to just disintegrate the atoms to be half. It is a long procedure. So half-life would mean if initially the thorium was 100%, it would be 50%, that is 0.5. Initially it was 100, right? Half-life would mean 50%, and the time at what? At time of this particular thing, 75, 381. So this is important to know. Every time you just can't write 100% that will reduce to 50. At what? At the half-life time. Now we will see a problem you'll understand better in this. Now here to determine the value of K and the equation of decay for thorium 230. Now here you can see you need to find the decay, okay, the K value, the decay constant. That is what you need to solve. So first of all, let's see what is known. Let's write the equation. The equation is over here, known. Now what is the A value? Initially, how much thorium was there? It was 100% thorium, right? Initially it was 100%. That means 100% is equal to 1. You can do it in the calculator. What is Y? What is the time? Time is how much? 75,381. That means at this time t, when t is equal to 75 plus k, it is 381. Y value will be 50% of the initial amount, okay? Whatever was taken, it will be 50%. Now, what is this 100%? 100% thorium, right? You can write 100 of x, that is 1x. This is what? 50%, 0.5x. That's it. Sorry, A initial value is A, right? You can just mention it as A, X, anything. It's just a variable, okay? This is what happens. Now here, Y, you can write it as 0.5 thorium. That's why I'm just writing X or A, anything is fine. Now this is equal to 1A. 1A, you can write just A. E to the power minus K is unknown. Let it be. Time is 75,381. This is it. Now, if you're wondering why 0.5, that means after 75,381, thorium reduces to half of its initial value, right? So that means it will be 50%. That is 0.5. Okay, half. Now what happens now over here? This is the thing. After, see, now 75,000 years are done. Again, next after 75,000, it will be 25%, because from 50 it will reduce to half of it. Then again to 75, again half. So it will be like long time until it fully disintegrates, you know. So that's why half-life is used for all this carbon dating and many other purposes. So now this equation, all you need to do is put in the calculator 0.5. Oh, one thing before we put X and X, sorry, this is not A. I'm very sorry, I'm clumsy, I'm doing many silly mistakes. Sorry for that. Now here 0.5x, 1x. What is this 1x? It was full thorium, 100% thorium. 0.5, half thorium, half 50% thorium, half-life. So you can cancel this and this. You're remaining with 0.5 equals e to the power minus k times 75,381. Just put that in the calculator as it is, 0.5. I mean, you can do the take natural logarithm on both the sides and solve. We have done it already, but now I'll just do it in the calculator. Shift E minus K is unknown value. Multiply it with 75,381. Shift and solve. The answer you get is 0. Okay, that's a huge. Okay, see, this is the thing. Okay, I thought it's wrong. Anyways, 0 point, that will be minus 6 means one digit is this, so it'll be 5 zeros. Let's write 1, 2, 3, 4, 5, 9, 19. Okay, now let's see. 1 2 3 4 5 6. Minus 6 means, yeah, that's correct. So it is 1 2 3 4 5. They have written 9 2 because 919, it will be 9 2. This is the answer. K value is that. Okay, it's an incredibly small amount. Now the rate of decay of thorium-230 is about 0.0000092, or about 0. Okay, if you're writing in percentage, you have to just multiply this by 100. Oh, sorry. This value, just multiply by 100, take 2 zeros out of this. Out of the 5 zeros, 2 are gone, you're remaining with 3 zeros. So it's basically 0.00092. It's okay. So the thing is, I was in equation mode. Now I'll get the answer. You should press on and then only you can solve it easily. 92 multiplied by 100, that is now this much percent. It's 3 zeros. Okay, that is the answer. Now you don't write it in percent, we just write it as the entire value itself. Now this is the equation for the thorium. Now there's part B in this. How much of 2 grams sample of thorium 230 should be left after 1,500 years? Now here what they have told us, the initial amount is given. How much of 2 gram? Sorry, the final okay, sorry. You know, when my mind is taking a lot of time to process things today because I'm not so well. Here they have asked how much of 2 gram sample. So initial value, imagine now you're in a lab, you're taking 2 grams of the sample. Okay, so A value is 2, so you're using 2 gram, and if you estimate this after 1,500 years, how much will be remaining if you keep it now? After 1,500 years, you can't wait so long, right? Let's do the calculation and see how much will it decay to. This is e to the power minus 0.00000092, and time is how much? 1,500. Okay, so that is it. Now here what you need to do is directly put this in calculator and you will solve. Just substitution, direct substitution. A value is that, and now direct substitution would give you 2 to the multiplied by e to the power minus 0.000092 multiplied by 1,500 years. You can see 1.97. That's the answer. It's done over here. That's it. Now you can imagine, you can make you know, this is a educated guess. What I mean is, you know, the half-life takes how much? 75,000 years, right? It's more than 75,000 years. So in 1,500 it will be just so little. If it was 75,000 years, 75,381 or 381 years, then it would be from 2 gram to 1 gram, half of it. But now since it's only 1,500, it will be very, very little. So only 0.03 grams are gone. You have 1.97 grams remaining out of the 2 grams. So this is it. It's written in words. Now that's a only 2-part question. Now here, please do try this problem. Pause the video, try it, and you'll get the answers. I hope you tried it. Now I will solve it. Here we have iodine 131. Now it is a radioactive isotope commonly used to treat thyroid cancer. Has a half-life of 8.02 days. Okay, so now what you want is the exponential decay equation. So let's write the first equation. Y equals a e to the power minus, don't forget the minus because we're dealing with decay, and kt. Now all you need to do is substitute what is given. Now here, okay, what is, we know the half-life. Okay, so it will be 0.5 half-life of amount of iodine 131 would be 1x e to the power minus unknown value of k, but the time is known to be 8.02 days. So how much is the k value? Just substitute this cancels, same like what we did just a while ago. Why? Because initially we will have 100% of the iodine. Half-life means 0.5, half of it. So 0.5 equals e to the power minus unknown value, that is k, we are finding it out, into 8.02. Shift and solve, you will get the answer 0.86. So that's the answer. But always remember this minus sign is there, that's indicating decay. So even if you don't remove, if you don't put this minus sign, you will get the answer. Sorry, shift and solve, you'll get negative answer. Okay, so this minus is important because it's reducing. I hope this is clear. And now here what they have told is how much of a 15 gram sample will be left after 20 days. So initially we have 15 grams of sample. So A is 15 into e to the power minus 0.086. And what is the time t? T is 20 days, after 20 days. So the answer is 2.69. Sorry, 2.69, 2.7 grams. So this is what will remain after 20 days. Now you can see, because half-life is 8 days. Now within 8 days it will be half of this. Then again 8 days, 16. Again half of that. And then, again it will be reduced. So it is 2.7 grams. And now we come to radiocarbon dating. So this is an interesting topic because they find fossils, they date them, age them and everything. Now here we have a real world problem. Archaeology. Carbon-14 is used to date objects in a method called radiocarbon dating. Carbon-14 has half-life of 5,730 years and a decay constant K of 0.00012. In 2016, charcoal flakes from the excavation site of an ancient human settlement in Canada were sent for radiocarbon dating. If the charcoal flakes were found to contain about 18.6% as much carbon-14 as they would have originally contained, how old are the charcoal flakes to the nearest year? Okay, it's a long problem, but we can break it down. So this main thing what we are dealing is about carbon-14. They have told the half-life, that means it reduces to half-life in 5730 years, and they have already given us the K value. Okay, now they have told there was some fossil found, charcoal flakes were found, and it contained 18.6%. So now what it says is, now initially there will be 100% of carbon, right? So it has been decayed. That means it has been given out, and how much is remaining in that? The remaining amount of carbon is basically 18.6%. So now if we know the half-life is so much, so if we keep on tracking, okay, in 5,730 it'll be 50%. Again after 10,000, 11,400 or something, 11,460, it'll be 25%, and then reduce it. We can come to know how many years. But instead of doing it in mind, we can use the formula and easily solve it up. Let's see. Okay, instead of all this, I'll just do it over here. Let's write the formula. Y equals a e power minus k and t. Now we don't know, we know what is remaining, right? How much is remaining? 18.6%. It is 0.0, wait, let me, 0.186 of carbon x, okay, equals, how much was initially? 100%, that is 1x. Here it's not half-life. Half-life was 0.5. Here they have told the percent. E to the power minus k. K is 0.00012. We need to find the time, unknown value t. I'm a bit lazy, as I told. Not lazy. I'm tired. I can say so. I'll directly put this in calculator, guys. But if you want to know how to solve this, we have already done problems before. The method is same. Okay, this cancels. X and x cancels. All you need to do is take natural logarithm on both the sides. This comes down and keep t at one side and everything else to the other side, and you can solve it directly. Now I will use the calculator here. 0.186 equals, E is shift and E, minus 0.00012 multiply it with the unknown value, unknown variable t, shift and solve. What's the time? It's 14,016 years. Yeah, that's approximately right, because 2 times this is 11,460, and then it's not exactly half of, it's not 12.5 again, it's more than 10,040, but less than 16,000. Yeah, this is correct. What I mean is, like, 50% half-life, or 50% half-life, it will take 5730 years. For again, it'll be 25%. You need to add one more 5730. If it was 12.5%, then it'll be 5730. So if you add all this, it'll be about 17,000, right? It must be less than 17,000, because why? 18 is somewhere over here, and it is more than 25, so more than 12,000, 11,000. So yes, this is in between. If you add these, it is around 11,460. Sorry, yeah, and then less than this. So approximately this is correct, but this is absolutely correct because we use the formula as well. So here in detail, much detail is there. You can go through this, about to understand better. But finally, the answer is over here. Where is the answer? That, okay, yeah. Did we get the same one? No. Where is the answer? I can't see it. They're telling the same method. It's between that 11,460 and 17,000. Okay, over here is the answer, T. Okay, see, all this is just extra explanation. It was very hard to find the answer. This is the answer, 14,017, sorry. It is 16.73, so you can approximate it to 14,017. So after 14,017 years, the carbon would remain to be 18.6%. So whatever the charcoal fossils they found is so many years old. This is a check, but you don't need to do check and all, because you got the correct answer anyways. If you want, you can do it. If you don't have time, just skip this part, directly go to the next problem. Now we are in this is the last problem. So we will quickly do this one now. Same problem, same type of problem, same method. Only thing is the value changes. Now here they have told it is 2.34% of carbon is remaining. That is equal to, initially it will be 100%. I'll write in percentage, okay? E to the power, what is the K value? It is 0.00012. We need to find the time. Okay, I did not read the problem, but I knew it's similar because all the values are given. That's why I wrote it out. Let me just make this right. This is percentage over here, and that is up, X is multiplied. Okay, now here an archaeologist examining a prehistoric painting estimates that it contains about 2.34% as much carbon as it would have contained when it was painted. How long ago was the painting created? Round off to the nearest year. Okay, that's going to be very, very long time ago. All you need to do is put it out in the calculator. Percent. Now I'm not going to write this X because it cancels. You're dividing both sides, this X and X, it cancels off. In such problem, you can just ignore this X. You can just write the percentage, it's enough. Equals 100%. It's 1, and at 0.0234, you can write it like that also. It's the same thing. E to the power negative 0.0012 multiplied with T. Shift and solve. Here is the answer. That is 3,000. Okay. Sorry. What did I do wrong? Okay, I have typed a 0 wrong. Okay, it's not 3,000. That's not, I know that because half-life is, 5,000 plus years. So, okay. It is 31,291.92. Okay. What I did, okay, this is a good thing. A good thing that mistake happened. I forgot to write 1 0 over here, and it gave me an entirely wrong answer because, not entirely wrong. I got 3,129. which is which was less than 10 times. So remember to write all the given values properly, and you need to press shift and solve, not equal to then equal to. You'll get the correct answer. It is 31,292. So this is the answer. This is the equation. It's very simple to solve. All the problems are just similar to this. Now over here, the value of carbon, K value, was already given. Sometimes they might give you the half-life and everything, so they'll tell you half-life of so much carbon is so much. You can find the K value like we have done in the previous problem. In the example 2, we used to find the K value and then we used to do this. So that is also important, because in the exam they may not give you the K value. They will give you the other details. So initial first step, you need to put the given final, like half-life value is equal to initial e to the power minus K is unknown. The time will be given, right? The decay time, the half-life time, that must be put over here. The time must be put, and then you must find the K value, and then you should use the formula. So this is the thing. This is how you solve this problem. If you have any doubts, please go back to the problems, the previous problems. Be thorough with the problems, and then try to solve more problems by yourselves. Then you'll be more confident while solving problems. That's it for this lesson, and that's the end of this module. I hope it has been useful. If you have not yet subscribed to my channel, I kindly ask you to subscribe it. It would mean a lot to me. Thank you so much, and I appreciate all those who are subscribed. Thank you so much to each and every one. And I will be recording the next chapter very soon. Please do stay tuned. All the best, guys. Bye bye for now.